Okay, so this is the senior review for the culminating activity, and I'm going to go ahead and do these problems with you. The first question on here is a subtraction problem. You can certainly put those in the matrix. So put the matrix, and go ahead and edit that matrix and put in the 2 by 2 matrix. Then we're going to go back in, put in the second matrix, which is 2 by 2. Then from your home screen, we're going to take matrix A and subtract matrix B. Oops. I just messed that up. Matrix A minus matrix B. So the answer is 15, negative 5, 1, 5. We cannot subtract the second one, so that's not possible because we have a 2 by 2 matrix and a 2 by 1 matrix, and they have different dimensions. For the addition, again, you would put those matrices in the calculator and add. So that gives you, sorry about that, I just cut that off. That gives you 8, 11, 9, 13, 8, and 6. So that's again the same process but with addition. The third, question number 4 on there, also not possible because they have different dimensions. This is a 3 by 3 and a 3 by 2, which you are not allowed to add. For number 5, you're just going to multiply each of these by the 2. If you would like to do that in the calculator, you certainly can. Do 2 times matrix A if you put this in as matrix A, or you just do your multiplication, and that would be 8, 12, negative 2, 20, negative 10, 4, whoops, 0, 22, and 2. Here, again, this is scalar multiplication. We're going to multiply each of these times 1/2, so you can do that in the calculator, 1/2 times matrix A, or just take half of each one. Negative 1, 0, 2, half of 8 is 4, negative 3, and negative 1. Okay, so to solve the matrices here for 7, 8, 9, and 10, for question 7 here, notice that this y minus 9 is here. We're going to set that equal to 1 because it's in the same position, and we're going to set them equal to each other and solve. So we add 9, and we have y equaling 10. So for number 7, that's the y value. For the x value, this negative 5x is in the second row, first column, so we're going to set that equal to the second row, first column here, and we have negative 5x equaling 5, divide, and we have x equals negative 1. So the two missing x and y values for number 7. Number 8, done the same way. 4y, right here, plus 5, because it's in the same position, equals negative 7. We subtract our 5. 4y equals negative 12. Divide, and y is negative 3. For the x value, this is over in the second row, first column. This is going to become negative 1 plus 8 equals x. So 7 is equal to x. For number 9 here, 3y is here, plus negative 4 is going to be equal to 11. Add our 4. 3y equals 15, and y is 5. To find the x value, there is an x value. So 4 plus x equals 3. Subtract your 4, and we have x equals negative 1. Number 10 is a subtraction problem. So we have 7y right here minus 1 equals 6. Add your 1. 7y is equal to 7. and we get y equals 1. For the x, we've got negative 3 minus x. Off the graph again, sorry. Negative 3 minus x equals negative 2. Add your 3. We have negative x equals 1. Divide by negative 1. X equals negative 1. Alright, these next problems here, I'm going to just do these in the calculator. So we are, we are taking a matrix that is 2 by 1, which is 12 and negative 4, and a second matrix that is 1 by 2, which is negative 10 and negative 7. And we're going to do matrix A times matrix B. You don't need a multiplication symbol in between the two of those. So this is going to be negative 120 negative 84, 40, and 28. And we're going to do the same thing with the next two problems and put those in the matrices and multiply. 25, 24, 25, negative 36. And the next one is 17, negative 29, 64, 18, negative 36, and 72. Okay, for the determinant of a 2 by 2 matrix, you can do it in the calculator or you can do it by hand. Sometimes it's just quicker to do this by hand. It's A times D minus B times C in a 2 by 2 matrix if A, B, C, and D are in these positions. So it's negative 9 times 2 minus 1 times 3, which is going to give you negative 18 minus 3, or negative 21. Number 15, 6 times 1 minus negative 3 times 2 is going to be 6 plus 6, which is 12 for the determinant. The 3 by 3 matrix you must do on the calculator. So we're going to go ahead and make a 3 by 3 matrix here. And this is 3, 1, 0, 2, 1, 1, 0, 3, 4. Now, again, whether it's a 2 by 2 or 3 by 3 matrix, these are done the same way. If we go back into matrix, so second x inverse, go to math and go to number 1, which is the determinant. We need to do the determinant of matrix A. So second matrix, under names, pick number 1, and it tells you that that is negative 5. So the determinant of this 3 by 3 matrix for number 16 is negative 5. Same one for the next one. We've got 2, negative 3, 4, 0, 1, and negative 2, 1, 2, and negative 3. And we're going to find the determinant of matrix A. Oh, shoot. All this is done in the wrong spot. You have to get in that home screen, and then we'll try it again. Determinant of matrix A, which is 4. Okay. Moving on to the next page here. Show the identity matrix for a 2 by 2 matrix. Well, that's when you have the 1s across the main diagonal and 0s everywhere else. For a 3 by 3 matrix, again, 1s on the diagonal and 0s everywhere else. If matrix A is 2 by 3 and matrix B is 3 by 1, what are the dimensions of A times B? Watch that that's saying A times B, not B times A. So A times B. So these are the same, so they give you permission, and so we are going to end up with a 2 by 1 matrix when we multiply. Okay, to find x here, to find x and y, x is in the second row, so we're going to have to multiply the second row by one of these columns. So if I multiply x times 7 plus 5 times 9 plus 6 times 11, this is in the second, we multiply the second row times the first column, so this is going to be equal to the second row first column number, which is 139. and we're going to solve that equation. So this is going to be 7x plus 45 plus 66 equals 139. I need my calculator. 45 plus 66. So this is 7x plus 111 equals 139. Subtract 111. So we have 7x equals 28. Divide by 7. And we have x equals 4. Whoops, here we go again. To get the y value, the y value here is in the first row. Let's go ahead and multiply that maybe by the second column, and then that will be equal to the first row, second column, first row, second column number, which is 64. So this would be 1 times 8 plus y times 10 plus 3 times 12 equaling 64. So this is 8 plus 10y plus 36. So this is 10y plus 44 equaling 64. Subtract 44. 10y is equal to 20. And y equals 2. So x is equal to 4, y equals 2. This is not the only way of doing this. You can multiply other rows times other columns to get the answers. If you have a 2 by 2 matrix, a quick way to determine if the matrix has an inverse is to find the determinant. If the determinant is not equal to 0, then there is an inverse. Okay, so for the next 4 problems, questions 22 through 25, they're all done the same way. You're going to go ahead and put the matrix in the calculator. So we're going to put a 2 by 2 matrix in here, which is 2, 3, 7, and 11. Okay, and then get back to your home screen. We're going to take that matrix and use this x inverse key, and it finds the inverse for you. So it's 11, negative 3, negative 7, 2. Yes, there was a way of finding the inverse by hand. You're taking a multiple choice test. Just use your calculator, okay? The next one, if you were to put that in the calculator, you would end up with 3/4, negative 1/2, negative 1/4, and 1/2. Third one again, if you stick that in your calculator, there is no inverse. If you wanted to make sure you did things correctly, remember, if the determinant is 0, there is no inverse, so negative 3 times negative 4 is 12, minus 2 times 6, which is 12, gets you determinant of 0. When you have a determinant of 0, you have no inverse. Finally, when you put the last one in, you get 1, 1, 5, 6 as the inverse. Okay, the next 2 problems are solving. So we need to, we're going to call this matrix A. The first one, we're going to call the second one matrix B. And then what we want to do is to take, this times x equals, take A inverse to kind of undo the A, to make the A go away. And then we're going to be doing the same thing on the left side. So to find matrix X, we're going to find A inverse times matrix B, and have the calculator do all the work for you. So how do we do this? So we're going to put matrix A in. So matrix A is going to be a 2 by 2 matrix. That is 5, 3, 3, and 2. Then we're going to go ahead and make a second matrix, matrix B, which is the 0, the 9, the negative 1, and the 4. And again, we are going to do matrix A, do the inverse, matrix B. And we get 3, 6, negative 5, negative 7. And that's our answer. So 3, 6, negative 5, negative 7. There is an extra step on 27. We first have to subtract this matrix. You are allowed to subtract matrices. This cancels out. I had to close the store. I'll be right back. Okay, so you obviously can put the matrices, these two matrices, in the calculator and subtract, or just do the basic subtraction on your own. So this is 9 minus 8, which is 1, negative 3 minus negative 2, which is negative 1, 6 minus 6, which is 0, 2 minus 1, which is 1. That goes in as matrix A. This other one on the right goes in as matrix B. And so you're going to do A inverse times B in your calculator, and you're going to get negative 3, negative 2, 4, and 3. Okay. Now we're moving on to our solving. We are going to be writing a matrix equation for each, so we're going to be making sure it's in standard form first, and then we're going to be stealing the coefficients. So this becomes 2, 1, because this is 1y, 3, 1, negative 3, negative 2, a 6, a 4, a negative 2, times xyz equals negative 1, 3, and negative 16. This is matrix A. This is matrix B. We do the same thing as we did in the prior page. To find xyz, we're going to do A inverse times B. Okay, so you're going to put this in as a 3 by 3 matrix for matrix A, put in a 3 by 1 matrix for matrix B, do A inverse times B in the calculator, and you're going to get negative 1, negative 2, and positive 1. And so the answer is negative 1, negative 2, 1, or you can write it as x equals negative 1, y equals negative 2, z equals 1. If you wanted to check your work, obviously you could put the x, y, z back into your equation, and it should work for you. Next one down here. Coefficients are 1, 1, and 2 for negative 1, negative 1, negative 3, 1, and 1, times x, y, z, because we have an x, a y, and a z. If it was two equations, two unknowns, you would just do an x and a y with the 2 by 2. And that's going to be equal to 4, 2, and 5. So to find x, y, z, this gets put into the calculator as a 3 by 3 matrix, matrix A. This gets put in as a 3 by 1 for matrix B. And you're going to do A inverse times B. And what you're going to get here is 7, 55, negative 29. So that is the ordered pair, ordered triplet here. It's not a pair, it's a triplet. 55, negative 29. For x equals 7, y equals 55, z equals negative 29. Alright, what they're now asking you to do is to do the reverse of what we did up here. They're giving you the matrix equation. They want the system of equations. So it's going to be this row times this column equals this number here. So 2 times x minus 1 times y minus 3 times z is going to be equal to 1. Second row times the column. Negative 1 times x, or negative x, minus y plus 2z equals negative 2. And again, this row times this column is going to give you negative 2x plus 4y plus 5z equals 3. So those are the matrix equations. 31 is asking us to solve this matrix algebraically. So I'm going to look at the x's, the y's, and the z's, and it looks to me as though it's easiest to eliminate the z. So I'm going to pair these two together, the first two, because they're already opposite each other, and then I think I'm going to pair the, what did I end up doing? The second and the third together. So our first step is to take x plus y minus z equals 2, and 2x minus 3y plus z equals 5. The z's are opposite, and we're going to add the equations together. 3x minus 2y equals 7. Second step down here is to take the second and the third equation, 2x minus 3y plus z equals 5, and 3x plus 2y minus 4z equals 3. We need to make the z's opposite each other, so this has a -4, so I'm going to put a +4 in front of this z here. So it becomes 8x minus 12y plus 4z equaling 20, and 3x plus 2y minus 4z equals 3. When we add these equations together, the z's cancel, which is what we wanted to have happen, and we have 11x minus 10y equaling 23. My third step then is to do linear combination with these two, because both of these equations now just have an x and a y in it. So we have 3x minus 2y equals 7, 11x minus 10y equals 23. Probably easiest to multiply to get the y's opposite here, so we're going to multiply this first equation by -5. So I'm going to just write this over down here. This is going to be -15x plus 10y minus 35, and 11x minus 10y equals 23, and we have -4x equaling -12. When we divide by -4, we have x equals 3. So now I have x. So I'm going to use one of these equations with just an x and a y in it to solve for y. So my next step is I'm going to just take the 3x, so 3 times x, which is 3, minus 2y equals 7, and solve that. Subtract my 9, -2y equals -2, so we get a y equals 1. Finally, take one of the original equations that have the x, the y, and the z in it, and we have x, which is 3, plus y, which is 1, minus z equals 2. Negative z equals -2, divide by -1, so z is going to be equal to 2. So our solution is 3, 1, 2, x, y, z. All right, last page here. Okay. Please solve by linear combination. That's also known as elimination. So I am going to make I think I'm going to do my y's opposite each other. So I'm going to multiply this equation by this number, this equation by this number, because that'll give you a -20 and a +20, and it will be opposite each other. So it's 15x minus 20y equaling 80, and 8x plus 20y equals 12. Add the equations together and we have 23x equals 92. Divide by 23 and x is equal to 4. Plug back into either original equation. 2 times 4 plus 5y equals 3. Subtract your 8. We get 5y equals -5. Y equals -1. And our solution is 4, -1. Next one, solve by substitution. So we're going to replace the y in this other equation with the x plus 3, because that's already solved or isolated for y. So this is going to be 10x plus 2, replace the y with the x plus 3, equals 18. Distribute 10x plus 2x plus 6 becomes, combine like terms, 12x plus 6 equals 18. Subtract, 12x is equal to 12, divide by 12, and we have x equaling 1. Then you can just simply go back to either equation, but obviously the easier one's the first one here because it's already solved for y. So y is equal to x plus 3, so that's 1 plus 3 is gives you a y value of 4. So the solution is, oops, off the graph here, 1, 4. Third one, solve algebraically any method. I would do this by linear combination. To make the x's opposite, I'd multiply by -2, and I'd have -14x minus 6y equaling -50, and 14x plus 6y, this should be an equal sign, not another plus, equaling 60. When we add these equations together, the x's and the y's cancel, but the right side doesn't cancel. If the x's and the y's and this right side canceled, it would be infinitely many solutions, because we'd have a true statement. It would be 0 equals 0. But this is a false statement. 0 is not equal to 10. So we write no solution. So they want a matrix equation, and they want us to solve using matrices for number 35. So we're going to take these coefficients, -3, -1, 4, and 8, times x and y, and that's equal to -1, -2. You're going to put this in your calculator as matrix A, the first one, put this in as matrix B, and to find x and y, you're going to do A inverse times matrix B. And when you put that in the calculator, it gives you 0.5, -0.5. Those answers are fine because they're terminating, but they weren't terminating. You'd press math, enter, enter, and it would convert it to the fractions. 1/2, -1/2. So that means our solution is 1/2, comma -1/2. Or you can say x equals 1/2 and y equals -1/2. Finally, you have to be a little careful in this problem here because it's not in standard form. This one right here, the second one's not in standard form because they want us to use matrices. So our first row is pretty easy here. This is a -4, a 3, and a 2. But our second row is not in standard form, so we have to move the 2y over by subtraction. Remember, there's a 0z that's not showing up, and that's equal to 0. So this is a 1, a -2, and a 0 for the coefficients. And then this is a 0x that's not showing up. So 0, 2y, so it's 2, and a -4 times xyz is going to be equal to -8, 0, and 14. Put this in as matrix A in your calculator. That's a 3 by 3 matrix. This 3 by 1 matrix goes in as matrix B. And again, to find xyz, you're going to do matrix A inverse times matrix B, and that gives you the solution. It gives you decimals. So once you get your decimals, press math, enter, enter, and it will give you 1/2, 1/4, -27/8. So that's a triplet here: 1/2, 1/4, -27/8. Reminder, this is an all multiple choice test, so absolutely make sure you know how to do your calculator. Use your calculator for solving matrices. All right, thank you.